Are you sure it's easier? In terms of physical or
Let's go ahead and put our mobile devices away and let's get started, guys. So on the homework,
chill out. Okay, what's on their card? I don't have anything. It's not real chlamydia to the people listening. Yes, you open my water. No, it wasn't. I know. We're still.
alright guys, let's stop talking about chlamydia, start focusing on calculus.
I'm pretty sure that was on the.
Okay. Y equals negative x squared plus 3. Everyone deserves a laugh, especially in math, every once in a while. Alright, so y equals negative x squared plus 3. It says find dy dx. Okay, so find the change in y or change in x.
I have a quick question. Sorry to interrupt, but what if I just like do it all right now? Would that count for anything, or you want to?
If you want to show me homework later on, please do so I can give you credit.
Okay, I'll do it.
Okay, so now we're moving on to the application of the shortcut. So when we take derivatives of polynomials, we have the power is going to drop 1. So here we have 2 coming to the front. So we have negative 1 times 2x. Drop this down 1 to minus 1, and then plus 0 to show every piece here.
You want us to show all of our work like that? Or
No, you don't have to show it. You guys can go right to what they want. So then this would be equal to negative 2x. So dy dx is equal to negative 2x.
Oh, okay, it just looks complicated.
Questions about this? Yes. Good. The derivative of any constant is 0. Because there's no change. All right, so let's go on to the next one then. Number 3. Number 3, we have y equals 2x plus 1. So dy dx would simply be 2. 1 coming to the front. And then dropping this down a power. X plus 0. And this is equal to 2 times x to the 0, which is just 2. The power of this was 1, even though it's not written. I don't know why it says minus 6. I'm still waking up. I don't know.
We all understand.
I was testing to see if you guys are paying attention, so good
I
job.
still need to give you back your pen.
1 minus 1.
I still have to. All right.
Anyone have any questions about these? Should be pretty straightforward, I think. And the next one, 5. 5, I think, is So looks a little different, but it's the same principle. It says y equals x cubed over 3 plus x squared over 2 plus x. I like to write, I recommend writing, I think it makes it easier to see that 1/3 as a coefficient of it, as a coefficient of x cubed. Now, when they say find dy dx for these problems, I mean, they could have said find y prime. They could have said find y prime. It's understood. Saying the same thing. So y prime or dy dx. Dy dx is a little more specific. It implies to what independent variable with respect to what, but here it's understood to be x. So the same process here, 3 times the 1/3. Drop this down, 1. Bringing the 2 to the front, dropping this down 1, plus bringing the 1 to the front, dropping this down 1. So y prime would equal 3 times 1/3 is simply 1. So you have x squared plus x plus 1. Again, just keep in mind, notice all the derivatives of polynomials are going to be functions that are just 1 degree less than the original function. That related to the last assignment where we looked at graphs and their y prime and saw the relationship with that. That's 5. And then the next problem is number 7. It says find the horizontal tangents of the curve. And we're given y equals x cubed minus 2x squared plus x plus 1. Okay, so for this one, you have to think about horizontal tangent. Horizontal tangent is going to be a tangent line that is perfectly horizontal, which would be perpendicular to the x-axis if we're graphed on an xy axis. So if you think about the definition of the derivative, again, there's 2 definitions that go hand in hand. One you can think of as it's the instantaneous rate of change of the function for any point on the function. And it also means it is the slope of any tangent line. That's what the derivative is. So if they want to know, they want to say find the horizontal tangent lines of this curve, y equals x cubed minus 2x squared plus x plus 1, I would need to set the derivative equal to 0, because I know that the slope of a horizontal line is 0. So this is the key here. Key is to say, okay, is to say let y prime of x is another way to write it. Let this be 0. Any questions about this? I'll make sure this is makes sense. No? Okay. So we'll go ahead and do that. So what is y prime? So y prime, knowing the shortcut, 3 to the front, x, drop it down a power, 2. 2 to the front would be minus 4x, drop it down a power, 1, I don't need to write, plus the derivative of x is now, you'll notice, is just 1. 1 to the front, drop it down a power to the x to the 0 power, 1 times 1 is 1. And then plus constants go to 0. So we need to let this B0. And again, y prime x, again, this is why I want to touch on notation, so it's all very clear. It means the same thing, y prime x, dy, dx. This is a very quick way to write it, y prime. So they say, okay, let's let this be 0. And now you guys are back to algebra 2, quadratic formula, or factoring, whatever.
Please go over how to factor it.
Yes, we'll complete it. Yeah, we'll complete it. If I can factor it, I will. If I can't factor it, of course, you kind of are forced to use the quadratic formula or complete the square. So if we were to factor this, we'd say, okay, AC method says 3 times 1 is 3. And the question is, what factors of 3 would sum to -4? Yes.
-3 and -1.
Correct. -3 and -1.
That's because you have the coefficient.
Can't have one.
Wait, what did you?
It factors out to 3x.
Oh, that's right. Long AC. Sorry. Let's see. Checking you guys. That would not be the same thing. Okay, so if you were to do it that way, you'd have to. Do you guys want to see long AC, or can I just jump to?
Can you
No,
go through the long AC?
Okay, I'll do long AC. That's fine. Yeah, that's fine.
Sorry.
No, that's fine.
Basic algebra skills.
No, you don't have to apologize. If you want to see it, I will show it every time.
Thank you.
Mm-hmm. So if we review of long AC, what you do is, okay, so AC, 3 times 1 is 3. What factors of 3 make up, what factors of 3, when add together, give me -4, be -1 and -3. So that's how I'm going to break this guy up. So all you do is you rewrite this and say, okay, 3x squared minus, and you know what, to be safe, because a lot of students can make a simple mistake, or anyone can, if you don't do addition instead of subtraction, because it just avoids the mistake that you can make when you, because then when you do associative, you don't have to worry about changing signs or anything, just make it all addition. It makes it a little bit more simple. Great thing about this method is that it doesn't matter how you group them. It doesn't matter whether if I wrote -x plus -3x or wrote -3x first plus -x, it doesn't matter. It'll still work out all the same.
If I got it, if nobody else needs to see it, but I just needed that.
We're gonna go ahead and finish it. So
Okay.
then from here, these two have what in common? They have x or -x, depending on how you look at it.
They got mine.
And you kind of get an idea of like where you want to go with it because you need this to match. So I'm going to take out a -x, leaving me -3x plus 1 plus -3x plus 1 equals 0. And then now you look at it like this. You say, okay, this guy and this guy are separated by addition. They both have -3x plus 1 in common, so I'm going to factor that out from each of them, leaving me -x plus 1. There's an understood 1 in front of any value. So the -x plus the 1 equals 0. Some of you might be comfortable enough to just go right from here to here. That's fine, but this is a process that will work. That will work every time.
Mr. Hutchinson showed you the tic-tac-toe method, Professor?
Did he show me the tic-tac-toe method?
Do you know it? Do you know it?
Do I know? That's probably a better question. No, I do not know the tic-tac-toe method.
I don't know it either.
Well, I'll put it this way. I may know it, but I may have called it something else. I can see it very organically. The way I always did these when I did these back in the day was I would just do this. I would say, okay, 3 times, how did I do it? I say 3 times 1 equals 3. And, no, that's not the way I did it. See, I've actually switched over to the way students, or most students, are being taught, which is the AC method. But I would just do this. I could do it in my head. I
I
could
think
say,
the AC method is a tic-tac-toe
So wait, is that what it is?
I would say, okay, look at this, and then look at factors of 1. And this may be the crisscross applesauce, tic-tac-toe, whatever the names they have for these things. So factors of 3, 1 and 3, factors of 1, because this is negative and this is positive, both negative, and then I would go right to there.
Which ones make -1? Being -1 and 3x minus 1.
Right, so one of these has to be, so this is the 3 here, this is the 1 here, and it's 3x, 1x. And then where do I stick these? Well, it doesn't matter because they're both -1.
The tic-tac-toe method is basically set up as A, and like it took 3 columns. First column is A, second column is C, third column is AC. And so once you multiply that, then you use B, and you have to like find the value. So like in this problem, it would be 3, 1, 3, and your B value outside would be -4, and you have to find what 2 values that equal 3 add up to -4, and that would be -3 and -1. And then you have to work through the multiplication through the line. Yeah,
It's you find the
it's
answer.
actually
really simple.
yeah, it's making it sound a lot more complicated.
For those of you that don't know how to factor, come see me after school. Otherwise, I assume you're good on factoring.
Is the AP Calc test particular about how we solve factor, or as long as we
Why do they care how you do it?
I mean, if you're on a section where you don't have a calculator, of course, if you do factoring, we can always just use the quadratic formula if you have that memorized. So if we complete this, then at x equals 1 and at x equals 1/3 is where we would have 2 horizontal tangents. Which makes sense if you understand, if you think about logically the graph of a cubic is typically going to have 2 changes in direction. So it makes sense that there would be 2 horizontal tangents. Now it says it says with the directions say find the horizontal tangents. So this is where they are. So the actual equations of the tangents, how would we do that? What do you think? Exactly, good. So if I plug this back into here, so this is where they are, but the actual equations of them. So we have y of 1 would be equal to 1 cubed minus 2 times 1, minus 2 times 1 squared plus 1 plus 1. So y of 1 would be equal to 1 minus 2 is -1 plus 1 is 0 plus 1 is 1. So y of 1 is equal to 1. So one of the horizontal tangents would be y equals 1. That's one of them. And the other one, you would do y of 1/3.
That's enough, it would just call it a day.
So then y of 1/3.
Do we have to plug it back in, or can we just leave it as like x equals 1 and x equals 1/3?
Yeah, the directions say find the horizontal tangents of the curve.
So if it's a vertical tangent, that would be x, but if it's a horizontal tangent, it's y.
Yeah. So this is one of the horizontal tangents. Let's be clear about this. This is, I graph this, y equals 1. You clearly see, I can see how that's the horizontal tangent of this. So even though the back of the book tells you where they are, the directions say find the horizontal tangents of the curve. It does not say find where they exist. It says find them. So give me the equation of the lines. Yes. May you get some water? Yes, you may.
But the back of the book is you're plugging in back into the original equation. You plug into the original equation and pops
Yeah,
up
so the back of the book does not say
So
that.
when
I
you find
understand
the
that.
y value, you have to to rewrite the whole equation with those y.
That's one of them.
Yeah.
Yeah, why are we doing y equals y not x like y?
Do you have to run the whole equation? No, because why you plug it back in?
We will look at it more in depth. Just in,
So it's 0 x, but it's also y. Oh, so they were y equals, so y can be the exact same. Yeah. Because it doesn't plug that in.
I don't know.
so we have 127. So 1/3 squared is 1/9. So minus 2/9 plus 1/3 plus 1. Can someone punch all this into a calculator, please? or I'll do it in my head too. I guess. Let's see if we get the same thing.
Okay.
Not out loud. Okay. I'm gonna get that. Sure, you're gonna do it out loud.
18 plus 9. 1927. That's what I think it is.
Am I correct?
That was a
1927. You said that's 1927. No, that's not it. Did you add 1?
Yeah, I did 27 over 27.
Because 1 alone. Well, never mind. Because you might use subtract, but still. I got something else. Let's see. Of course, it won't give it to me in fraction form. So it can be here or whatever.
So it's 1 minus 18 plus 9 plus 27.
I'm just going to do it.
I got 31.
Oh, it's 6. Oh, I multiplied it wrong. That's why.
-5, 4, 31, 27.
Yes! It's not 31.
Here's the other solution.
That's gonna come up on the recording too.
So the answer to the question, because the question in the direction said, find the horizontal tangents of the curve. Y equals 1 and y equals 31/27.
How come that's not the answer?
Because they weren't paying attention to what they wrote.
Great.
Probably.
Love it. Love it when the book makes
Somebody with
mistakes.
the book last year.
Love it when the book makes mistakes.
I wish we were using this one, not to get off subject or anything, but usually the thicker the textbook, the better the textbooks. I wish we were using
Our
one.
math, have you seen the math textbooks over there? They're like, they're thin.
Is anyone confused about this? About this problem?
I feel like it would help me to like do just one more, like just to go through the whole process.
Like this one.
Okay, if we have time, we will do that. That sounds like a good idea.
Tell me one more time.
Yes.
Why you plugged it back in.
Okay, so why I plugged it back in was because, think about what I found here. I found that the horizontal tangents, where they exist when x is 1 and when x is 1/3. And I know that any horizontal line is y equals some constant. So once I find the value of the function at x equals 1, then y equals that would be the horizontal one going through that point.
I got carrots again. Does anybody want a carrot?
I hate
That's number
carrots.
7.
Oh my god.
And we have 2 more problems. Let's see if we can get through
Maybe
them.
I'll try carrots.
Number 13.
Why did you get us like that?
So many things just happened in this man's attention. Oh my god.
You just put a whole bag.
Alright,
You can
guys.
take a bar if you want it.
I wish I had some.
So this says let y equals x plus 1 times x squared plus 1. Find dy dx a by applying the product rule and b by multiplying the factors first and then differentiating. Of course, I would do b all day long, but we're going to show that we know how to do both. So by applying the product rule. So by the product rule, which is part A, we're going to say y prime is equal to product rule says take the derivative of the first, leave this guy as it's written, the other factor, the second factor, plus leave the first factor as it's written, guys, please stop talking, times the derivative of the second factor. And then simplifying from there. I'm not going to go.
Wait, why did you do 1 times that?
So y prime is equal to, if I do the product rule as it states, product rule says derivative of the first factor, which is 1, leave this guy alone, plus leave the first guy alone, the first factor alone, times the derivative of the second factor. That's product rule, and that's from, I think, yesterday's lesson, the shortcuts. And then from here, I'm not going to go any further because you guys should be comfortable simplifying that. And then part B, by multiplying the factors first and then differentiating. Does anyone like to see part B? Raise your hand if you'd like to see part B.
No, I got that.
I would be glad to do it. Anyone wants to see part B? Thank you. All right, so part B. So part B, we have by multiplying the factors first. So if we multiply the factors first, we would have to FOIL. So if we FOILed this, we would have x times x squared is x cubed, x times 1 is x, 1 times x squared is x squared, and 1 times 1 is 1. And then I'm going to simplify this before I take the derivative, which I can't because there's no like terms, so it's ready to go. So I'm just going to rearrange it in descending power, just because it looks nicer, and that's the way it's usually properly written. And then now take the derivative of this. Each term is individual, so 3. Yeah, so one thing is that addition separates, you can do derivatives of each term individually. So 3x squared plus 2x plus 1, which would be the same result if we simplified this, should be. Okay, the next one we have is number 37. Support your answer graphically. Find an equation of the line perpendicular to the tangent to the curve y equals x cubed minus 3x plus 1 at the point 2, 3.
Were we supposed to graph that? Well, that's an graph. It didn't say that.
On graph.
It said what a graph means, so I just, I did algebra.
Yeah, you didn't have to do it graphically, you just had to like.
Did we have to do a graph? Or did we get full credit for doing algebraically?
It says support your answer graphically.
Do they want a graph or?
I did not. I think they probably want a graph, you don't have to do it. Like you just have to do it however you do it, and then you graph it.
Like you do it and then graph it to show that you're right.
Yeah.
So for the curve, if it's tangent, it has a perpendicular thing to it. There we go. It's graph.
Is that like a plus sign on it? Like what is that?
Find an equation of a line perpendicular to the tangent to the curve. So a line that's perpendicular to the tangent, that's called also known as the normal. So we know that. Go ahead.
Reciprocal of the slope.
What's that?
How to find the opposite reciprocal of the derivative? Like you do the inverse.
Okay, so.
You have to plug in.
All right, so guys, so what I was going to say is that the derivative gives you the slope of the tangent line. So once you find the slope of the tangent line, then you know the slope of the normal line, which is what they want here, is going to just be the opposite reciprocal. So let's first find what would be the slope of the tangent line. So y prime of x would be equal to 3x squared minus 3. And they say so at the point 2, 3. So I want to know y prime of 2, which would be 3 times 2 squared minus 3. which would be equal to 12 minus 3, which is 9. So this says that the slope of the tangent line at the point 2, 3 of this function is 9. So therefore we know the slope of our normal line is negative 1/9. So therefore, I'm just going to write m, you guys know what m is. Slope of the normal line is negative 1/9.
Yeah.
Okay, so we have that piece of information. Do we have a point that exists on this line? Yep, it would also be 2, 3. And there, I don't care whether you use point slope form or slope intercept. Oh, okay. I was like, is there some joke about point slope and slope intercept? I don't know.
There. It's all like
Yeah, that's one dirty word you didn't know.
All right. So,
I have a video from that class, and no one is doing
I
anything.
love that video.
The one on the desk. I remember.
You're like, you said that.
Oh,
I said that.
I did something that was so fast. I don't know what I tried to work something. I don't know what I tried to do something and it didn't work. I'm like,
It's on my computer.
Okay,
I think I have
it. Like, send me that video.
What are you going to be like at the end of this year? Mr. Gross is going to about 10 minutes. Mr. Gross, you're going to be done with this.
You're guilty already.
Sorry, Mr. Gross. He's done with you.
is okay what? Yeah, you can expand it, that's fine. You can write it as y equals x plus b, that's fine. I'm fine with you guys stopping here and then point, if it's asked on a test, find the equation line, you can stop right here at point slope. You don't have to write it y equals x plus b format. Now to support this graphically, we're going to imagine that Mr. Gross is graphing.
Look, I did the beautiful one. Look.
He's graphing this cubic. He's graphing a cubic. He's graphing a cubic, not a quadratic. So imagine that it is a cubic, which is going to look like this, like that sideways S. And then I would then graph a tangent line at 2, 3, and then just show another line perpendicular to that line. And you'd be like, aha, I see.
It's beautiful now.
But I think, is anyone not comfortable graphing something like this in a graphing calculator?
How do you do that?
We need to start using this tool. We're going to start going into that. But anyone not comfortable with that? Graphing a cubic?
Well, I haven't done that.
You're not?
Never used one.
I've
Never used one. So if you have one now, go ahead and get it out. And remember that if you need to rent one from me, you can come see me before or after class and make sure you have one of those forms that are filled out. There's more of the forms on the back table in one of those in the tray. Oh, thank you.
Oh my God. It's open.
Have you seen that video?
Guys,
The video from AC?
we have 7 more minutes of class where I read all standing around.
We're going to share a
Sit down. Sit down.
Sit down.
So on your graphing calculator, you hit y equals in the upper left-hand corner. And you can punch it in. Y equals x cubed minus 3x plus 1.
It's not working.
It's not powering on.
It's on. The y equals button is not working.
Is that the one that you rented?
Yes.
Okay.
I haven't done anything with it, so I promise.
Wait, can you put it up under the camera thing?
Yeah, why don't we do that now?
So go ahead and punch in your y equals x cubed minus 3x plus 1.
Wait, where do we get?
And then you hit, I believe it's enter, and it'll graph it.
Yeah, the first enter goes to the next line.
y equals x cubed minus 3x plus 1. So x is right here. And then raised to the third power, you can carry it here, minus 3x plus 1.
Okay, this sheet.
Yeah, sure.
Sorry.
Alright, so then after you graph that, you can then set this, bring the add 3 to both sides, and then punch that into, and you'll see that that would be perpendicular to what would be the tangent line. You could also graph a tangent line and just have that
You would just
come up
graph
to
that
form the tangent
line.
line.
You
What's
would have to
that?
graph the original function too, right? And then graph the line.
Yeah, so after you've punched this one in, you graphed it, you're going to go ahead and you can graph this line here. But your calculators need to be our y equals, so just make sure that you add 3 to both sides. And you would see that that would be perpendicular to what would be the tangent line at 2, 3. If it doesn't go through 2, 3, you know that you've made a mistake, and maybe that's the idea of supporting your answer. The idea of supporting your answer,
Is that it makes sense?
yeah, which is good. You should be able to see something, understand it graphically, and support your answer graphically, so it makes sense to you.
So if they ask us to do some of the tests, what are they expecting us to answer? Do they want us to draw out a graph? It's a serious question, like what would they want us to do?
If it said to support your answer graphically, yeah, a quick sketch by hand, and you can use, if you had your graphing calculator, you could do that. I probably won't ask you to support your answer graphically. Okay, but it's just good just to have a natural understanding, like, okay, I can see that this would be the tangent line, this is my normal line. It does make sense to me. The AP test does focus on knowing things graphically as well as without graphs, so it's a good thing to always relate the two. Yeah. Any questions about this problem? Anyone? Please raise your hand. No. Do you guys want homework for the weekend? Okay.
Are you really gonna ask that? Come on, I think you're smart enough.
If the answer was yes, I would have assigned some. All right, so let's go to 3.4. Let's look at some other little small pieces before the bell rings. So understand this, that this is the way it works. If you have a position function, the derivative of the position function is the velocity function. And the derivative of the velocity function is the acceleration function.
Is this like, okay, I don't.
Guys, we have a really bad habit of just shouting out stuff, and it's really annoying. I don't know if you guys are able to tell that by my body language and my tone of voice, but I doubt in the college setting you just shout things out. So, and the derivative of acceleration function is the jerk function. Now think of it like this. What is the rate of change of someone's position? Their velocity. For those of you that have studied physics, you kind of have a hand up on this. For those, and then the rate of change of velocity, how fast velocity is changing, acceleration. Rate of change acceleration, jerk. So this is where the derivative is moving down. Actually, let me do it better than that. So if this is P of X, this would be P prime of X, this would be P double prime of X, and this would be P triple prime of X.
So is this just like
There we
second
go.
derivative, the third derivative, and the fourth derivative? So if they give us a position function, we're gonna find the derivative a few times to get the jerk function.
Yep.
Cool.
Exactly what you have to do, yep. Of course, we're going to be, AP Calc exam problems are tougher, but we'll get to them when we can get to them. A lot of these problems we can't look at yet because a lot of them deal with integration. So, That's the general idea, to understand that. So if you went the other way, when we start getting integration or anti-differentiation, the integral of the jerk function would be an acceleration function, and so forth, going the other way.
Thank you.
Thank you guys. Have a good rest of your, enjoy your weekend.
Here's my homework question.